In this video, I'm going to discuss how to solve quadratic inequalities. Actually, there are many methods can be used to solve the quadratic inequalities. In this video, I'm going to use two methods. One is graphical method and one is algebra method. Graphical method is using graph to find the answer, whereas algebra method is without using graph. Let us start from the graphical method. To solve the quadratic inequalities by using graphical method, the very first step, of course, is to sketch the graph of the quadratic. After sketching the graph, we need to mark the region of the inequality. Then, based on the marking, the range of the values of x is obtained. To sketch the graph of the quadratic, again, there are many techniques can be used. For example, we can use transformation, or factorization, or completing the square, or separate the quadratic, or perhaps any other methods that you know. Now, let us start trying this question. The first step, sketching the graph. In this question, I'm going to use transformation to sketch the graph. Based on the quadratic given, we have learned that the graph is a U-shape because the coefficient of x power 2 is a positive value. The turning point of the U-shape is at the origin. Then, minus 2 means the curve is transformed 2 units downwards. Next, we need to find the x-intercept. To do this, we set the quadratic to 0 because at x-intercept, y is equal to 0. Then, we got the values of x. To solve the inequality, we are interested at finding the range of values of x. So, just simply ignore the y-axis in order to focus at the x value. After sketching the graph, I'm going to mark the region of the inequality. Since the inequality is less than and equal to 0, which means that the region below the x-axis should be marked. From the marking, notice that the range of values of x which satisfy the inequality is from negative square root of 2 over 5 to positive square root of 2 over 5. Then, the range of values of x is written in set notation as final answer. However, many students solve the inequality by using the same working steps as in solving equation, which is not acceptable. Another mistake is the final answer is not written in set notation. Next, we try the second inequality. To solve this inequality by using graphical method, first I'm going to sketch the graph. Since the coefficient of x power 2 is a negative value, then the curve should be an N shape where the turning point is at the origin. Positive 3 means shift the curve upwards for 3 units. Then find the x-intercept. Now the graph is ready. Next, I'm going to mark the region of the inequality. Since the inequality is less than or equal to 0, then which means that the region is below the x-axis. From the marking, notice that the range of values of x which satisfy the inequality is x less than or equal to negative square root of 3 over 2, or x is greater than or equal to square root of 3 over 2. Then finally, the answer is written in set notation. Next example. To obtain the graph of this quadratic 9x squared plus 2, I simply shift the U-shaped curve upwards for 2 units. Then I'm going to mark the region of the inequality. Since the inequality is greater than 0, then I should mark the region of the graph which is above the x-axis. Notice that the whole graph is above the x-axis, which means that I need to mark the entire graph. In another word, all the values of x satisfy the inequality. Then finally, the answer is in set notation, all the values of x where x is the real number. For this question, if the inequality is less than 0, then I should mark the region of the graph which is below the x-axis. But notice that the whole graph is above the x-axis, so no region of the graph is marked. This means that there is no any values of x satisfy the inequality. So conclusion, no solution for this inequality. Now let's move on. In this question, the quadratic expression consists of 3 terms. To sketch the graph, I'm going to do factorization. After the factorization, I got 2 linear factors. From the factors, then I got 2 different roots of the quadratic. One is negative 3 from the factor x plus 3, and another one is 1 over 2 from the factor 2x minus 1. Since the coefficient of x power 2 is a positive value, so the graph is a U-shape. Based on this information, then I can sketch the graph. Next, since the inequality is greater than 0, then the part of the graph which is above the x-axis should be marked. So, the solution is x less than negative 3 or x greater than 1 over 2. And this is the common mistake made by many students when solving quadratic inequality. So, students, please take note. Now we continue to another example. When solving inequalities, most of the time we prefer to keep all the terms on the left-hand side and 0 on the right-hand side. Since there are 3 terms, so I'm going to do factorization. But I found that factorization cannot be done. In this case, completing the square can be used. To do completing the square, the coefficient of x squared should be equal to 1. So, I factorize the 2. Now, completing the square can be done in the brackets. The product of the completing the square should be in this form. This value is obtained by using the coefficient of x times 1 over 2, and I got negative 3 over 4. This value is the square of this value, and I got 9 over 16. Now completing the square, done. After completing the square, we need to simplify the expression. First, we expand the 2. Then we combine the constant, and at the end, we got something like this. After completing the square, now I'm going to sketch the graph by using transformation. First, the graph is an U shape because the coefficient of x power 2 is a positive term. Then the turning point is at the origin. X minus 3 over 4 means shift the graph to the right for 3 over 4 units. Then minus 17 over 8 means shift the graph downwards for 17 over 8. Next, I'm going to find the x-intercept. In this case, I use the formula to find the x value. Now, the graph is ready. Since the inequality is less than 0, then the part of the graph which is below the x-axis should be marked. Hence, based on the graph, the solution is x is greater than 3 minus square root of 17 over 4 and less than 3 plus square root of 17 over 4. Now let's try another example. For this question, since factorization cannot be done, so I'm going to do completing the square. First, I factorize the 2. Next, I multiply negative 2 with 1 over 2 and I got negative 1. Then the square of 1 is 1. After simplifying, then I got something like this. After finished completing the square, I'm going to sketch the graph by using transformation. I start from U shape where the turning point is at the origin. Then I shift the graph right hand side for 1 unit. Then I shift the graph upwards for 9 units. Now the graph is ready. Next, I need to mark the region according to the inequality. Since the inequality is greater than 0, then I should mark the region of the graph which is above the x-axis. Notice that the whole graph is above the x-axis, which means that I need to mark the entire graph. In another word, all the values of x satisfy the inequality. So therefore, the solution is all the values of x where the x is real number. Now let's try another example. When solving the quadratic inequalities, besides sketching the graph by using transformation, I can also sketch the graph using other method. That is, I can separate the quadratic into 2 different graphs, where I shift 5x minus 3 to the right hand side becomes negative 5x plus 3. And I keep the term 2x power 2 on the left. Now I got 2 different functions. One is y equals 2x power 2, which is a simple quadratic, and another one is y equals negative 5x plus 3, which is a linear function. Now I'm going to sketch the 2 different graphs on the same axis. First, this is the graph y equals 2x power 2. and this is the graph of y equals negative 5x plus 3. After sketching the graph, now I'm going to mark the region according to the inequality. Based on the inequality, the quadratic is greater than the linear, which means that I should mark the region where the curve is above the straight line. On the left-hand side of the diagram, notice that the curve is above the straight line. So this is the region that we want. Then we move on. At the middle part of the graph, notice that the straight line is above the curve. And this is not what we want. Then on the right-hand side of the diagram, once again, the curve is above the straight line, which is what we want. Therefore, the solution should be the range of values of x which is less than a value x1, or the range of values of x which is greater than a value x2. Now I'm going to find the values of x1 and x2. To do this, simultaneous equation can be used. This will produce two values of x. One is 1 over 2 and the other one is negative 3. So, definitely the smaller value x1 is negative 3 and the bigger value x2 is 1 over 2. At the end, the solution is x less than negative 3 and x greater than 1 over 2. In this question, in case the inequality is less than 0, and when I separate the quadratic expression, then I'll get the inequality 2x squared less than negative 5x plus 3. So in this case, we should mark the region where the curve is below the straight line. So from the diagram, the middle part of the graph is what we are looking for. So the solution is x is greater than negative 3 and less than 1 over 2. Now we move on to the second method where we solve the inequality without using graph. For this question, first we shift the constant to the right. Then I square root the both sides. We know that in SPM level, students would say that square root of x power 2 is equal to x. But in STPM level, square root of x power 2 is actually equal to modulus of x. So we replace square root of x squared with modulus of x. According to the properties of modulus, if modulus of x is less than a constant k, then the range of values of x is greater than negative k and less than positive k. Therefore, when we go back to the question, modulus of x less than or equal to square root of 2 over 5, then the range of values of x is greater than negative square root of 2 over 5 and less than positive square root of 2 over 5. Then finally, remember to write the answer in set notation. Now let's move on to another question. To solve this question, first I shift the constant to the right and I got x squared greater than or equal to 2 over 5. Then I square the both sides. Square root of x power 2 is equal to modulus of x, so I replace square root of x power 2 with modulus of x. According to the properties of modulus, if the modulus of x is greater than a constant k, then x is less than or equal to negative k or x greater than or equal to k. So for this question, when the modulus x is greater than or equal to square root of 2 over 5, so the range of values of x is x less than or equal to negative square root of 5 or x greater than or equal to square root of 2 over 5. So finally, the answer is written in set notation. Now let's move on to another example. For this question, when I rearrange the inequality, I found that x power 2 is greater than a negative value. But we know that x power 2 should be a positive value. So I'm going to ignore this step. Instead of saying that x power 2 is greater than negative 2 over 5, which is not true, then I prefer to say that x power 2 is greater than 0, which is true for all the values of x. And since x power 2 is a positive value, and if I multiply the positive value with 5, then 5x power 2 should be a positive value too. And if I continue to add a positive value 2 to 5x power 2, then the result is still a positive value. Therefore, the conclusion is 5x power 2 plus 2 is always greater than 0 for all the values of x. So, the conclusion is all the values of x satisfy the inequality. Next example. When solving this inequality, first I shift all the terms to the left. And since there are 3 terms, so first I try to do factorization, but I found that factorization cannot be done. Then I perform completing the square. After completing the square, then I got something like this. Now I'm going to solve the inequality without using graph. So first I shift all the constant to the right hand side. Then square root the both sides. The square root of x minus 3 over 4 power 2 is equal to the modulus of x minus 3 over 4. According to the properties of modulus, the range of values of x minus 3 over 4 is between negative square root of 17 over 4 and positive square root of 17 over 4. And last, when I shift negative 3 over 4 out, then I've got the range of values of x between 3 minus square root of 17 over 4 to 3 plus square root of 17 over 4. So finally, the result is written in set notation. Next example. To solve the inequality, I found that I need to perform completing the square because factorization cannot be done. Then after completing the square, then I got something like this. And now I'm going to solve this inequality without using graph. So when I rearrange the inequality, it shows that x minus 1 squared is greater than a negative value. Instead of saying that x minus 1 power 2 is greater than negative 9 over 2, it is more suitable to say that x minus 1 power 2 is greater than 0, which is true for all the values of x. Since we know that x minus 1 power 2 is a positive value, if this positive value is multiplied by a positive value 2, the result is still a positive value. Then when I continue, if this positive value plus a positive value 9, then the result is still a positive value. So at the end, 2 times x minus 1 power 2 plus 9 is greater than or equal to 0 for all the values of x, which means that the solution is all the values of x satisfy this inequality.